Assalamu alaikum. How are you, my dear students? Hope you will be fine and okay by the time you are watching this video. Today is our lecture number 26, same unit 14, electromagnetic induction. In our today lecture, I will explain to you the alternating current generator, the AC motor, or the induction motor. So let us start with the alternating generator first with the name of Allah Almighty. Alternating generator or AC generator. AC generator. Now, what is the AC generator? AC generator is the device which converts mechanical energy mechanical mechanical energy into electrical energy into electrical energy. The working principle of the AC generator is based on the phenomena of electromagnetic induction. The working principle. What is the working principle? The working principle here is based on the phenomena of phenomena of electromagnetic induction. Electromagnetic electromagnetic induction. Whenever there is relative motion between magnet and a coil such that there is the change of magnetic flux, then induced EMF will be generated. The induced EMF generated for the AC motor can be written as like this induced EMF generated, the induced EMF generator will be E max into sine 2 pi f into t. Here, this E max, this is the maximum voltage we can obtain, or the maximum induced EMF. The maximum induced EMF generated. This maximum induced EMF generated, later on I will be showing to you that this is depends on the number of turns, area of cross section, and the strength of the magnetic field, and the angular speed of the generator are simply Nawab. You remember this, and you know this is all constant. Therefore, any generator have a fixed value or a constant value, maximum constant value for the induced generator. Now let us see that the what is the structure of the generator. Structure. The AC generator consists of a powerful radial magnet, a powerful radial magnet, right? This powerful radial magnet which you see here generate magnetic field strength B. This is the magnetic field strength B. And we have another one, the armature. Armature is in fact the assembly of coil and axle on which the coil is mounted so that it can freely rotate, the armature, right? So it includes a coil of the, let I label the coil as PQRS, PQRS of many hundred turns, many hundred turns. Let's say I say this n number of turns. Okay, it is then mounted on an axle which is placed between the poles of the magnet. This is a coil. It is mounted on an axle, right, by using bearings, and it is placed inside the magnet in such a way that it can freely rotate. So that is the armature. So it is actually the assembly of the coil and the axle. And we have the copper slip rings are just, I will label it the slip rings. These slip rings I will mark as S1 and S2 in my diagram. You see here that this is the copper slip ring. If I label it as the S, like this S1, then it's this S2. Okay, these copper slip rings are used to draw, are they are connected to the they are permanently connected to the ends of the coil and are used to draw the current or to take the current from the coil and then to pass on to the external circuit. Here you see in by using the carbon brushes. The carbon brushes are in loose contact with the copper slip rings, and then the carbon brushes, let's say that brushes I label as X and Y in my diagram. The X and Y, these carbon brushes are in permanent contact with the external circuit but in loose contact with the copper slip rings, and this is how they passed on the current. Now the derivation of this equation and the working. There is another important point, I'm sorry. The external power source. Yeah, external power source. External power source. This external power source is mechanical energy. Mechanical energy, which keep the coil moving inside the magnetic field. So a moving coil, I think dynamic example of the dynamic induced EMF, the moving coil in a static magnetic field. So you see here the working. Now look, as the coil is rotated, as I told you, that there is the NP QRS of the coil, right? So the segment of the coil, the PQ, the QR, and the PS segment of the coil, we will look into these, that, and you know that the only PQ and the RS segment of the coil will contribute to the induced EMF, right? Because they can be used to get a change of flux, and the QR and the PS, of course, no, because they will always remain parallel to the magnetic field. Their motion will always remain parallel to the magnetic field. So it wouldn't reduce it wouldn't produce any sort of the induced EMF. So now let us see that the FUC, look at this case here, as the coil is rotating, then there will be a change of flux in that through the magnetic field, and that change of flux will cause the induced EMF reduce, and that induced EMF will be then passed on to the external circuit. Here now look, the induced EMF, there are two things that is actually related with the induced EMF, and those two things which are related to the induced EMF produce the induced EMF, the magnitude of the induced EMF and polarity, magnitude and the polarity, and the magnitude and the polarity of the induced EMF change in time. they are what? They change in time. This is why it is called the alternating current, which direction changes many times in a second. Now here, now just see a magnified view of the diagram here. Now look, you see that first, if the look in the first case, when the coil is in the vertical position, in the vertical position here, there is the magnetic flux here. When the coil is in the vertical position, then the induced EMF through the loop of the coil is zero. Why? Because the change of flux is minimum or zero in this position. So I will also tell you that you remember that whenever the coil is moving parallel to the direction of the magnetic field, then the induced EMF will be zero. But in the next case, the flux will be, the change of flux through the coil will be maximum. It will be maximum, and in that place, because you see, look, the velocity of the segment PQ of the coil, here you see that it is moving through the magnetic field and it cuts through more lines, and this is why there will be greater induced EMF. Change of flux will be maximum. The change of flux will be what? And the change of flux will be maximum at this point. And in this way, this is the current at this point will be what? Maximum. But here again, now when it takes the vertical, the loop when it takes the vertical position, then what happens? That the change of flux decreases through the magnetic field, and it becomes zero completely when the coil becomes in the vertical position. So again, no induced EMF. But in this case, as the coil continue to rotate, this time the rotation of the coil is such that the sides PQ and the RS now changes side, right? The PQ approaches the south pole while the RS approaches the north pole. So in these ends, the induced EMF produced will be now in the direction opposite. Clear? And again, the flux will now start increasing, but this time in the opposite direction, as you see here. And the flux will be maximum after 3/4 of its quarter of the its cycle. And similarly, after completing one complete rotation, when the coil comes back in the vertical position, then the flux will be zero. Again, the change of flux will be zero, and there will be no induced EMF in the circuit, and it will become zero. So sorry. Now let us see that was for the, so you have seen that the polarity continuously changes. Now let us see that, as we know that as we know that flux is equal to what? That the flux is equal to the, through a single loop, is equal to B dot A. But if there are n number of turns, then it will be directly proportional to the number of turns, and it will become equals to n into BA into cos of theta, where theta is the angle between B and the area vector of the loop. Now, and this theta is equal omega by T, or we can write this as 2 pi by T into T. Now look, you can just see your maximum induced EMF by using this condition, and I'll be coming to this one. Now for the rate of change of flux, according to the Faraday law, the rate of change of flux is equal to delta pi by delta T, where the negative sign indicates the direction of the induced EMF and can be found by using the Lenz law. Now here you see that, look, this will be equal delta T into the delta t into the n into BA into cos theta. Here the rest of the factors are constant like n, b, a. These are constant, and this change with respect to time will be cos omega t. So if we take the limit as applying the limiting condition here, we will write it like this, that this instantaneous induced EMF, the induced EMF instantaneous is equal to n BA into the limit at the smallest interval of time delta t tends, when delta t tends to 0, then we can write that delta by delta t into cos omega t, and this is a pure mathematical function, and mathematically this term is equivalent to this term is mathematically this term is equivalent to equivalent to minus omega into sine omega t, right? For the bio student, it will be difficult, but you don't need to poke your nose with these difficult things. You have only to remember this mathematical equivalence, right? Because it is beyond the scope of your syllabus and only the mathematics students may know them, right? So this is just a direct result and you need to write the direct result here. Now, look, we can write this instantaneous like this, that this will become equal to n a omega b into sine omega t, right? As I told you that this omega t, there as I told, look, that theta is equal to what? It is equal to omega t, and in turn omega t is equal to what? 2 pi by t. So for even your MCQs, you can just see, look, your t can be 0, right? This is capital T. Your t, what happens when t is 0? What happens when t is half of the time period? What happens when t is equal to t by 4, and then half, quarter, half, and when you have the t equal 3t by 4, and when you have the 3t by 2, and when you have the t equals t, then how your induced EMF will then look. So this is your time, and this will be your induced EMF. So you just put this value. For example, when t is equal to 0, sine of 0 is 0. When t is equal to t by 4, then what will happen? T, capital T by 4. So t will get cancelled and 2 will get cancelled. So pi by 2, and you know sine of pi by 2 is maximum, and you have the maximum induced EMF. As later on I'll be explaining to you that this I instantaneous is equal to induced EMF max into sine omega t. Now why max? Because the number of turns in the coil is constant, area of cross section is constant, it has a constant angular velocity, and it has a constant magnetic field. So this has a fixed value, and this will be definitely measured in volt. Measured in what? In volt. Because you know this is potential difference or induced EMF, so its unit must be in volt, because this is a mathematical function and it has no unit. So you see here that this t will become equal to what? Pi by 2. So when it is equal to pi by 2, so you have the plus E maximum. Now when you have the t is equal to t by 2, so it will be equal to t cancel, 2 cancel, pi, sine of pi is 0, and there will be no induced EMF at this position. And if you see your graph, look how you will label it. Just this is one time period, and you see this is half of the time period, and this is quarter of the time period, and this is 3t by 2 of the time period, right? And then this is t. So you just see, look, that there will be what, just in the same way that it will be corresponds to, this is t, so it will be corresponds to 2 pi, it will be corresponds to pi, it will be corresponds to pi by 2, this is t by 4, okay, and it will be 3 pi by 2, so this is 3t by 4, I'm sorry, okay, so 3t by 4, very sorry for that. So here when it is, when you have the 3t by 4, then what will happen, 3t by 4, so again you will be having pi by 2, it will be maximum, but it will be this time it will came out to be like 3t by 4, so it will came out to be 3 pi by, it will came out to be minus 270, so means minus 1, 270, so it means minus 1, and it will become E max like this, okay, and similarly 0. So these are the points where you can get the positive maximum value of the induced EMF and the negative maximum value of the induced EMF. And the positive and the maximum induced EMF, they are equally important, okay. For example, look, this portion of the induced EMF, this portion is equally important is like this portion, clear, both are equally important, right? But the difference is that the current flows in the opposite direction, the rest is the same. And now you see here, look, as I told you that this is the E max maximum value, and now when I just write the instantaneous value, then the induced, that is the instantaneous value for the induced EMF, turns out to be E max and sine 2 pi f into t, where f is the frequency of the generator. Usually this frequency is from 50 to 55 hertz in our country, Pakistan, right? So you see that the induced EMF changes in time, right? It changes both in polarity and magnitude in time. It depends. Why? Because that, look, if this t changes, then the value of the sine 2 pi f t changes, and you have the E instantaneous changing. And so this is all about the AC generator. Now there is another important topic, and that another important topic is, this is the AC motor, or sometimes this is called the induction motor. AC motor, AC motor, or the induction motor. Now why it is called the induction motor, I'm coming to that point. The induction motor, this is completely different from the DC motor. Both have one thing common, they convert what, they convert electrical energy. Just like a DC motor, the induction motor or the AC motor convert electrical energy into mechanical energy, into mechanical energy, into what, into mechanical energy. But this AC motor or the induction motor has a different working principle, and here the working principle is based on the phenomena of the induced EMF changing in, that is what, it is based on the phenomena of what, the sorry, the AD current, the best one. The AD current that reduced in one coil may cause the rotor to may cause the motor to run, right? Look, the how it happens, I'm coming to that point right now. You will see here in this way. The AC motor has usually two basic important parts. The one part is called the stator, right? The stator, that is the stator is the uh, fixed part, right? That is what? That is the fixed part of the motor. Fixed. It is what? It is fixed, right? Non-rotatable part. And the rotor part, that is the dynamic part of the motor. Now, look, this is best than the DC motor because of the two reasons, that the current passed through the motor is without commutator. There is no commutator in the AC motor or induction motor. Contain no commutator or copper split rings Second, no direct connectivity to the external electrical source. No physical, no physical connectivity to the external power supply. So these 2 points keep it an advantage over the direct current motor, the DC motor. Now, and this gives it a long lasting life, right? Because no carbon bushing or such things are required here. Now you see that what happens, the stator consists of the set of electromagnets, as you see here, like this one. These are the electromagnets here, like this one, like this. So there are the group of the electromagnets which are arranged in the way that they form a hollow cylinder. The hollow cylinder is such that there can be easily fitted the rotor inside it. Rotor is the rotating part of the motor. Now, what happens that when the stator part, the electromagnet, when it is provided with the current, so here you see the wiring, now there is produced a magnetic field. Now the rotor part also consists of the electromagnet, which are also arranged in a cylindrical form with the pole facing towards the stator poles, right? What they cause then, this electromagnet, they some of the electromagnetic lines pass through the rotor and they produce induced EMF in the coil, and that induced EMF causes the rotor to turn on. So this is actually because of the AD current which is produced in the coils of the rotor. That induced EMF produces its own magnetic field, and the two magnetic fields interact together and they give rise to a mechanical force or couple which keep the rotor moving. So that is one of the important features of the DC motor, that it works on the phenomena and the concept of the AD current and use no commutator or no direct connection. So the magnetic field produced by the AD current interacts with the rotating field of the stator, and this creates a couple of torque in the direction of the rotation, and the motor keeps moving. So that is all for today. Thank you very much, and inshallah see you in the next lecture.